Graphing linear functions using slope-intercept form. So we finally made it here after doing lots of work with this all-important formula y equals mx plus b. We are finally going to use it to actually graph functions, and I think you'll see that since we've already been working with it so much, this is actually going to be pretty easy, this video. So slope-intercept form, that is just a formal term for this form right here, y equals mx plus b. And up until now, every linear function we've been dealing with has been in that form, so we're going to start off by just keeping things that way. Let's graph y equals 2x plus 4. So you probably already can figure out how to do this. But when we're graphing, it's going to be easier to start with the y-intercept. Start with the y-intercept of 4. So we count up 4 right here. That is going to be our first point right there. And our slope right here is 2. So what that means is we go up 2 to the right 1, plot a point. Up 2 to the right 1, plot another point. Now we can go in the other direction. Just follow the same pattern. Just like that. And once you have a good amount of points, we can just connect the dots and put an arrow on the ends to show that the line goes on forever. Just like that. Alright, let's do one more. Like that one, y equals x plus 1. So here we have a y-intercept of 1 right there, and a slope of 1. So we go up 1 over 1, up 1 over 1, and since we could have lots of points really close together here, but that's just going to be more work. So let's just kind of trace this line up, follow the diagonal. Whoops. Okay, so that's one point up there, and then if we go the other direction, we're just doing a perfect diagonal line. And now we could just draw straight through all these points here. So there we get a nice full graph that stretches the entire length of this picture here, if that's what you want to do. Okay. And again, that's not really necessary since you have the arrows on the end that show that the line goes on forever. Okay, let's throw in some negative numbers here. So we got a y-intercept of negative 4 and a slope of negative 5 over 2. So what this means is we can do where y changes by negative 5 and x changes by 2. So if y changes by negative 5, we're going to go down 5. And then x changes by 2 will go there. Or if we want to go the other direction, then we could have y changing by 5 and x changing by negative 2. So y changes by 5, x changes by negative 2. So we're going to go right there. Okay, and then we can just draw this line. Oops, let's make it a little more accurate than that. There we go. It's not perfect, but you get the idea. So again, the slope is negative 5 over 2, so either one of these fractions is negative 5 over 2. But that's just a way to write it out. All you have to remember for slope is that positive slope goes in that direction, negative slope goes in that direction, and then you should be fine. Okay, let's try something a little different. Y equals negative 8x. So our y-intercept here is plus 0. Plus 0. 0 is just not even shown there in the equation. And negative 8 means we're going to go up 8 and then left 1 right there. And then the other direction will go down 8 and right 1. So this is almost a vertical line, but not quite. Alright, let's try y equals 5 over 2x plus 1/2. So here we have a y-intercept of 1/2, so right in the middle there. Now the problem with this slope here, 5 over 2, is that if we use that and just go up 5 and over 2, we're going to be stuck between grid lines. So let's try to get back on the grid line, and here's how we're going to do that. Let's look at this slope in a different way. Instead of saying up 5 over 2, the slope also just means how much the y changes every time x changes by 1, right? Because it's just a ratio of y to x. So that's what another definition for slope. So what this is saying is every time x changes by 1, the y changes by 5 over 2. So that means we're going to go up 5 over 2 and right by 1. Get it right on the line there. See, now we're back on the grid line, so that works out. We went up by 5 over 2 and right by 1. Another way to look at that would be we also just took this fraction and divided the numerator and denominator by 2. So we had 5 over 2 over 2 over 2. So you can manipulate this slope fraction in any way you like, because it's just a ratio of change in y to change in x. Okay, and now we can go back to the regular 5 over 2 and go up by 5 over by 2 like that. Let's go the other direction. We're going to go down by, actually here we'll do the same thing first. Let's go down by 5 over 2. That'll be right there. And then to the left by 1. There we go, right there. Okay. And now we'll go down by 5 and left by 2. So you want to definitely do that if you're stuck between grid lines, especially with a fractional y-intercept like that. You want to get back on the grid lines by manipulating this slope here. Okay, let's try another one of those, because that can be a little tricky. We're going to have y equals 1/6 x minus 5 over 3. So minus negative 5 over 3 y-intercept is going to be, let's see if I can get it right there. Okay, yeah. So now we have a slope of 1/6. So if we have to keep going up by 1 and over by 6, up by 1 over by 6, that's going to be messy because we're stuck between grid lines. So how about this? Let's say we want to go up by 2/3 here. We want to go have a change in y of 2/3, right? Because if we have a change in y of 2/3, we'll get on this line right here. So how do we manipulate this fraction so that we have 2/3 in the numerator? Well, we'll have 2/3 over 4, because that will be equal to the 1/6 here. So that means we're going up by 2/3 and then over by 4. And this is a slope of 1/6. 2/3 over 4 is the same as 1 over 6, so it's still the same slope. And now that we're back on the grid line, we can just do the initial slope we were given, up 1 over 6, and it'll be right there. Now going down from here, let's see, what else can we write? We want to go down by 1/3. I want to go down by 1/3, so we're going to go down by 1/3. It's a negative 1/3 change in y. So when we go down by 1/3, how do we get back to 1/6? Well, it's going to be negative 1/3 over negative 2. So that means we're going to go down by 1/3 and left by negative 2. As you can see, when we connect these lines here, we'll actually just do one point. We'll go down by 1 and over by 6. Now we connect these lines here, we get a nice straight line because we drew all our points perfectly accurately. Okay, anyway, hopefully you get the idea with that. So go to our horizontal line. Y equals -6. This is very easy. If y is always -6, we find where y is -6 right here, and it's a straight across horizontal line. Y is always -6. Same thing with our vertical line. X equals 9. Where is x9? X equals 9 over here. So we see anywhere on this line, x equals 9. This is 9, 0, 9, 1, 9, 2, 9, 3. X is always 9. Okay, now let's change things up a bit. And now we're going to do something that is not in the y equals mx plus b form. It is not in slope-intercept form. Y minus 2x equals 3. Well, we know we can still graph this because we still have an x and a y. But the question is how? Well, we have to transform this equation so that it is in y equals mx plus b form. So y equals mx plus b, if you think about it, that's basically just solving for y, because we have y isolated by itself on one side and everything else on the other side. So let's move the -2x over to the other side, and we'll get y equals positive 2x plus 3. And now we can very easily graph this. We have a y-intercept of 3. And we're going to have a slope of 2. Look something like that. Now let's start with -2y plus 3x equals -4. So let's move the 3x over, so we have the y's by itself. -2y equals -3x minus 4. And now divide both sides by -2 to get y equals positive 3 over 2x plus 2. And again, now we actually transformed into another equation that is very easy to graph. Okay, now for the last one, let's throw in a lot of stuff. -3x minus 5y minus 2 equals 3. So let's see if we can do this all in 2 steps. We want -5y by itself over here. So let's move everything else over. The -3x will become positive over here, so we'll have 3x. The -2 will become positive, and added to the 3 will become 3 plus 2 equals plus 5. Now we divide both sides by -5, and we get y equals -3/5 x minus 1. So minus 1, -1 y-intercept. And now negative slope goes in this direction. So that means we're going to go up by 3, over by 5, and then we're going to go here, we're going to go down by 3, over by 5, and there is our graph. Okay, so we're going to end the video here. Next time we're going to take a look at how to graph equations in this non y equals mx plus b form faster using a different method.